Well students, last class we have seen about the Rutherford alpha scattering, and we had seen the experimental setup, how the alpha particle gets collided with the gold foil, and we seen the scattering angles and other things. Now we will continue further, okay. We will see another concept, distance of closest approach, okay. So what this actually the distance of closest approach? We know that an alpha particle directed towards a nucleus will experience a repulsive force. Why? Because alpha particle is positively charged as well as nucleus is also positively charged. Let me consider nucleus over here and an alpha particle is directed towards a nucleus. Okay. As the alpha particle approach nearer and nearer to the nucleus, what happens? Velocity of the alpha particle goes on decreases. Why? Because of the repulsion. So it goes on decreases at a particular point. Okay. So let me take a distance r0 from the center of the nucleus where the alpha particle stops. Okay. At this point alpha particle stops and it retraces the same path. Okay. So after stopping at this point at a distance r0 from the center, it retraces the same path with an angle difference of 180 degree. Okay. So it retraces with an angle difference of 180 degree. So what happens at this point actually? So when the alpha particle comes near to the nucleus, it will have kinetic energy, right? It will have kinetic energy, what we call half mv square. As it reaches nearer and nearer to the nucleus, this kinetic energy gets converted into electrostatic potential energy due to the two charges. Okay. So at this point, kinetic energy entirely gets converted into the potential energy and the particle stops. Okay. Then it retraces the same path. So the distance r0 from the center of the nucleus where alpha particle stops and retraces the same path is called as distance of closest approach. So this is the definition. It might be asked for 1 mark. The distance from the center of the nucleus where alpha particle stops and retraces the same path. Okay. So according to law of conservation of energy, we can write loss in kinetic energy is equal to gain in potential energy. Correct, right? So energy, what does the conservation of energy says? Energy cannot be created, it cannot be destroyed. What we can do? It can be converted into one form to the other form. Okay. So here loss in kinetic energy will be equal to gain in potential energy. I can write the equation whatever we have seen here, half mv square, that is equal to 1 by 4 pi epsilon naught 2 Z square divided by r0. What is this 2? 2 is atomic number of helium. Okay. Then Z is atomic number of nucleus. We don't know which nucleus. We can take any nucleus. Okay. Now we can rearrange this equation. We can take this term to the other side. Okay. Then taking r0 to this side, we will get this equation, which is r0 is equal to 1 by 4 pi epsilon naught Z square divided by kinetic energy. Kinetic energy is nothing but half mv square. Okay. Now this r0 is nothing but distance of closest approach. With this value of r0, by finding this value of r0, we can find out the size of the nucleus. Correct, right? So till a point, okay, where the nucleus has got the strongest area, the alpha particle can reach. After that, it will not be able to move further, right? So the boundary or the distance up to which the alpha particle can reach will be the size of the nucleus. So we can make use of this formula for r0 is equal to 1 by 4 pi epsilon naught Z square divided by kinetic energy to find the size of the nucleus. So let me take gold atom. Okay. So what you have used in your alpha particle scattering experiment, right? Gold atom. It has got atomic number 79. So kinetic energy of the alpha particle whatever we have used there was 5.5 mega electron volt. 5.5 mega electron volt, it is nothing but 5.5 into 10 to the power 6 into electron volt getting converted into joules. So it will be 1.6 into 10 to the power minus 19. Okay. Now we will substitute the value over here. Yeah, you know one more thing, right? You know 1 by 4 pi epsilon naught. What is you have studied in your first chapter. It is 9 into 10 to the power 9. By substituting these values, you can do the calculation. We will be getting an answer. Okay, this is not important. This is important. So this can be any value if you go with the different atoms. Okay, but this value is very important because size of the nucleus is of the order of 10 to the power minus 15 meter, or we also call it as 1 femtometer. 10 to the power minus 15. Okay, this is about the idea of finding size of the nucleus. So you can do this calculation by yourself to find out the value. So this value will be 41.3 of the order of 10 to the power minus 15. Okay, we will move on further. Next concept what you need to study is the impact parameter. Okay, so impact parameter, you can first define it. It is a perpendicular distance of initial velocity vector, okay, of alpha particle from the center of the nucleus. So here I have drawn a diagram. You can see here this B is nothing but impact parameter. See here, it is a perpendicular distance of initial velocity vector, okay, of alpha particle from the center of the nucleus. So let me consider an alpha particle moving over here. See this. So this is an alpha particle. When this alpha particle moves near to the nucleus, okay, the distance, if I take from this particular point, the closest path, okay, the distance of closest approach can be R0 over here. Okay, it is R0 from the nucleus. That is already been discussed. Now we will focus on this one. It is a perpendicular distance. So this distance with respect to the center of the nucleus is taken to be impact parameter. Why this impact parameter is important? Why do we need to find out? We need to find out it because trajectory of the alpha particle depends on the impact parameter. Okay, I'll give you a brief idea. If the nucleus is over here, this is the center of the nucleus, and let me consider an alpha particle moves like this. So this is B. Okay. So let me consider the first case. When B is very small, that means B small means the alpha particle is moving very close to the nucleus. Okay, alpha particle is moving very close to the nucleus. What happens then when alpha particle moves very close to the nucleus? It will have more impact, right? So actual path should have been like this, but it will get scattered with the large angle. When B is small, theta is large. At the similar way, when B is large, that means I'm taking somewhere over here. So the same B can be somewhere over here. It won't be affected with the influence of nucleus. Correct, right? Why? Because it is C. Nucleus is over here, alpha particle is moving over here. So it won't have any influence at all. They won't see each other. Okay, so never mind. When B is large, angle of scattering theta is small. Okay, when B is large, theta will be very small value. Okay, now we will go to B is equal to 0. What is the meaning of B is equal to 0? See here, B is equal to 0 means it comes directly with the nucleus, center of the nucleus. So what happens at the point when it comes directly to the nucleus? We know, right? When it comes like this, it will go rebouncing in the same path, making an angle of 180 degree. Correct, right? So theta is equal to 180 degree. So impact parameter is important because trajectory of particle, alpha particle, depends on the impact parameter. Okay, that's all about this one. It may be asked for 1 mark. Okay, we will move on further, like we will go back to the same thing, whatever we have studied. So we will go bit detail about Rutherford atom model. Okay, so what we know about Rutherford atom model, we have already seen, right? It says that every atom consists of a central core called nucleus, correct? Which contains all of atom's positive charge and most of its mass. So nucleus, okay. So this is the center of the nucleus. This can be taken as nucleus. Okay, so if it is an atom over here, nucleus contains almost all the positive charge and most of its mass. Okay, then the second point, radius of the nucleus, we have already find it, right? It is of the order of 10 to the power minus 15. Nucleus of the order of 10 to the power minus 15. What is radius of atom? Radius of atom is 10 to the power minus 10, or we call 1 angstrom. Okay. Nucleus occupies very small portion of the atom. See, if you just check the difference between these two powers, 10 to the power 15 and 10 to the power 5, you will get a difference of 10 to the power 10, you will get a difference of 10 to the power 5. See, the atom is such a big, nucleus will be very small within it. Okay, so that is the idea about nucleus. Electrons occupy space outside the nucleus. See, Rutherford says electrons doesn't come over here. Electrons are outside this nucleus, and what do? They revolve around circular path, right? So atom is electrically neutral. Why? Because nucleus contains positive charges, electrons are negative charges. Whatever positive charges are there in the nucleus, equal amount of negative charge will be there on the electrons. So positive negative cancel each other. Okay, so atom is electrically neutral. Now next point, electrons are revolving around the nucleus in circular orbit. See, this is important. Electrons are revolving around circular orbit. So this is the idea what Rutherford put forwarded. We will see the remaining idea of Rutherford's atom model. Well students, we will see another important derivation which may be appeared for 5 marks from this chapter. Expression for total energy of electrons in stationary state of hydrogen atom. Okay, we have to find the total energy for an hydrogen atom. So we know one thing, the centripetal force required for an electron to revolve around the nucleus will be provided by what? The force of attraction between nucleus and the electron. Correct, right? From that concept, we can write mv square by r, that is the centripetal force. Okay, that is equal to what? The force of attraction, electrostatic force of attraction, 1 by 4 pi epsilon naught Ze square by r square. Okay, so we will do one thing here, we will cancel r. See, both the r radius is there in the denominator, so we cancel them. Okay, now we are going to get an equation mv square, that is equal to 1 by 4 pi epsilon naught Ze square by r. See, r got cancelled, we get 1r. Okay, I'll take this term to this side, rearranging. Okay, this term to this side. You get this equation? See here, r is equal to 1 by 4 pi epsilon naught Ze square divided by mv square. Okay, now we will find it for hydrogen atom. So you know, right, atomic number of hydrogen is 1. We will substitute Z is equal to 1 over here. R will be equal to 1 by 4 pi epsilon naught. Z goes to 1. E square divided by mv square. So this is the equation for radius of an hydrogen atom. Okay, now we will go for the total energy. Remember this equation, mv square is equal to 1 by 4 pi epsilon naught Ze square by r. We need to carry it. Okay, total energy is equal to kinetic energy plus potential energy. Correct? So what is kinetic energy? We know already, mv square by 2 or half mv square minus, why minus? Potential energy is minus. Okay, minus minus 1 by 4 pi epsilon naught Ze square divided by r. Okay, now this mv square, that's what I told you, should remember this. This will be substituted over here. So what happens to the equation? In the denominator 2, okay, 1 by 4 pi epsilon naught Ze square by r minus 1 by 4 pi epsilon naught Ze square by r. So you can clearly observe this one. Okay, next what happens here? I'll multiply these two, then I write the denominator 1 by 8 pi epsilon naught Ze square by r. Okay, minus 1 by 4 pi epsilon naught Ze square by r. Now you see here, this equation is similar to this. 1 by 8 minus 1 by 4. You know, right? This is a smaller number minus bigger number. Correct? So what happens? You will get a smaller number, right? Minus 1 by 8. So that minus comes over here. Minus 1 divided by 8 pi epsilon naught Z square by R. So whatever we have done here, the same thing we will substitute for hydrogen. Z is equal to 1. You get this equation. E is equal to minus E square divided by 8 pi epsilon naught R. So this is an important equation. Okay, you have to remember it. It will be asked for 5 marks and moreover chances. Okay. After that, we will see the limitations of Rutherford theory. Why Rutherford theory failed? See, Rutherford theory came after this J.J. Thomson, right? So he disproved his sir. J.J. Thomson was the sir, like he was the master of Rutherford. So Rutherford disproved his ideas and he came up with a new idea. But his ideas also did not work much. It did not last forever. Okay. It was discarded due to some of the reasons like this. See, we know Maxwell, right? So Maxwell gave one idea that whenever a charged particle accelerates, okay, it will give out an electromagnetic radiation. So I can show you here. See, this is an atom. See, electrons are revolving in circular path, right? We have seen the postulate of Rutherford theory. So you see here, at every point, what happens? The direction of velocity is tangent to the direction of circular motion path, right? So that means velocity changes. Velocity changes means, you know, right, dv by dt, it's acceleration. See, that means when an electron revolves around the circular path, at every point it gets accelerated towards the center. Okay, so that's a reason why when Maxwell says accelerated charged particle should continuously emit electromagnetic radiation or electromagnetic wave. Now the same thing, when electron revolve around circular path, it must radiate energy continuously, okay, and finally it will fall into the nucleus itself. See, every point it radiates energy means it loses its energy. So finally it will come to the nucleus and fall into the nucleus. So there is no concept of atom at all, right? So when electron falls into nucleus, then it's gone. Okay, so no concept of atom. So stability of atom was not able to explain with this theory. Okay, another one, during inward spiral motion. See, when electron revolves like this, the inward spiral motion, what happens? Angular frequency increases continuously. Okay, angular frequency increases continuously. Therefore, what happens? Electron must emit EM waves of all frequencies. See, if it is a continuous emission, then we will have all the frequencies, right? But what experiment shows? Experiment shows that atoms emits line spectra. Line spectra means, like, see, one energy level over here, another one over here. So there is a difference. It is not continuous. So, and also each line spectra has got a particular frequency or wavelength. So that was not able to explain by Rutherford theory. So that Rutherford theory got discarded. Okay.